Hello everyone, thanks for coming, thanks for having me here. My name is Mario Heiderich. I'm a researcher and a postdoc at the Ruhr University in Bochum, and I wrote my PhD thesis about client-side security and defense, so mainly cross-site scripting attacks and the like. I have a small penetration testing firm. We do consulting workshops and trainings and stuff like that. Wrote some books, wrote some papers, and published some tools that are mainly focused around security, around injection attacks and defense. I invoked the HTML5 security cheat sheet, which is a public documentation that you can use as a developer to find out whether your application is safe by just copying these strings and they're analyzing these strings and testing if they bypass your injection filter. And I tweet a little bit, and you can write me emails if you feel like it, and that's about that. My personal research focus is mainly browser security and everything that is happening inside lesser than and greater than. And I'm a big fan of markup. I like HTML 2.0, and I even like HTML 5.1 and the upcoming versions of HTML6 and HTML the living standard and all these things. And I also like JavaScript, JScript, which is fundamentally different, of course. I even like Visual Basic Script, which makes me probably a bit of a crazy person. I've done a lot of research in direction plugins and ActiveX controls, editable rich text as well. SVG, as in scalable vector graphics, mathml, XLS, XDR, CSS, scriptless attacks, so attacks that you can use to exfiltrate data from unsuspecting users without using any scripts. I've been working a lot with ECMAScript 5, ECMAScript 6, DOM clobbering techniques. The only thing that I don't do at all in terms of security is like binary stuff, because my brain is just too small for that. I have a lot of focus on offensive security, so injection scenarios, active file formats, parser analysis, so I try to actively bypass parsers and find bugs in the parsers. And some things that I really like is just like, I call it legacy porn. It's just like the old features, the ancient features that we just learned about some minutes ago that are deep hidden in the browsers but still active and still usable, and you can find bugs in there and exploits, and that really gets me going. I also like the defense part, not as much as the offense part, but I like to analyze cross-site scripting filters, web application firewalls, intrusion detection systems. I had a lot of time that was spent with CSP, the content security policy. I was working on DOM-based cross-site scripting filters, DOM policies, trusted DOM, and these things. And that's basically what I do. And you might wonder why we have another talk about HTML, because I think there was a lot of talks about HTML already. But I think that HTML is kind of on its way to ultimate power. So we not only see websites and applications out there, but we see HTML being used in instant messengers and email clients and local documentation of your favorite IDEs and presentations, as we saw during the last days, and router interfaces, even in coffee machine UIs or fridges. And apparently, and according to this source, we even see HTML as the interface language for medical devices, which I find shit scary, because I don't want to have a pacemaker that is having a web interface and totally flexible and field upgradable via web interface. I don't know. Let's try it out. Maybe it goes well. So we see operating systems that are almost entirely built on HTML, at least the UI layer. We see Windows 8. We see Tizen from the Linux Foundation. And we can see that the combination of HTML, the DOM, and JavaScript is incredibly powerful, and that even browsers are heading towards becoming like actual operating systems. And if you have a look at freaking Gmail, for example, I was curious and I measured the amount of JavaScript that Gmail uses to load and display a single mail, and that's about 3.5 megabytes. So it's 3.5 megabytes of compressed JavaScript that is being pushed to the browser and does stuff. Like, who wants to debug that? Like 3.5 megabytes? So we're not talking about small web apps or something like that. It's just like full stack applications that do a lot of things and are extremely, extremely complex. There has been a lot of research in terms of defense. So we all know scripting or injection attacks. Like, we have some user input and we don't sanitize it properly, so the attacker does some stuff and then the website does something else, like something that is unexpected. And against that we have defense mechanisms, and there is many of them, and these mechanisms exist on various layers. So we have like network-based defense, like some products look into packages and do stuff in there. We have IDS and IPS systems that prevent and detect intrusions. We have web application firewalls that I think don't make any sense at all, because usually they don't work. We have a lot of server-side defense that exists. Mod security can be used to filter the stuff that is coming in, or at least detect attacks, and many others. And we also have client-side defense. We have XSS filters in Internet Explorer, in Chrome/WebKit. Firefox is going to get an XSS filter soon, according to what I heard. We have CSP that is being standardized by W3. By WG and W3C right now. We have NoScript, like this tiny little extension by Giorgio Mahone that is keeping attackers from attacking us. often, but sometimes not. And usually with all these defense tools, it was like, we tested it, we bypassed it, they fixed it, we tested again, we bypassed it, they fixed it again, and so on. So it's just like an ever-rolling thing that is going on. And there's also a lot of documentation on the defense, like sometimes even good documentation, sometimes pretty shitty documentation. There's hundreds of papers, talks, blog posts, etc., covering injection attacks and how to deal with them and what to do about them. And the three horsemen are covered quite well. You may ask, what kind of three horsemen? And now it gets a bit biblical, because I found out that the kind of ways of using XSS, or the kinds of cross-site scripting, kind of resemble the horsemen of the apocalypse. So we have reflective XSS, so reflected cross-site scripting, which is just coming by a get parameter, by a post or cookies, but it's transparent, like you can see it, like something is going on in your address bar. And it resembles of the white horse of purity, easy to understand, easy to detect, easy to prevent, just filter your output and done you are. Then we have the stored XSS. That is something that persists on the storage medium of your server or whatever you're delivering your sites from, and it resembles of the red horse war. It's harder to detect, it's hard to prevent, and especially when you need rich text, or if you want your users to submit HTML to beautify their profile page or something like that, then you need to tell the good things apart from the bad things. So you need to allow some of the HTML, but you disallow other parts of the HTML that could potentially be active. So it's a bit harder. And then there's, of course, DOM XSS, this kind of cross-site scripting that happens only in the DOM. So it resembles of the black horse disease. I think that's the best term we can find for it, because we cannot really fix it. There is no way to detect it. And the only way to actually approach DOM XSS attacks is to write safer code. Like, there is no other defense mechanism right now. We cannot use the server to defend against that or any filters, because, well, the server doesn't see what's going to happen. It's all happening in the DOM. It's happening with document cookie or document URL or document location. And there's a source and there's a sink, and then an alert pops up or something worse happens. Another question is, we've seen 3 of these horsemen, but what's a proper apocalypse without the 4th horseman, of course? And this is the 4th horseman. And this is actually one awesome statute in, I think it's in Bulgaria. No, it's actually in Hungary. And this 4th horseman is, in my opinion, an entirely new class of attack, an entirely new kind of XSS and cross-site scripting, and it's something that, well, we don't have too many defenses against, and I want to show you what I mean. So, but enough of the kitsch, and let's get actually technical and see some source code. If we talk about cross-site scripting attacks, and if we talk about defending against these kind of cross-site scripting attacks, then we need to use some assumptions. And the first assumption is for reflected cross-site scripting attacks. And it says, like, we assume that this stuff comes in via the URL, via parameters, and if we just go ahead and filter the input or the output, depending on what we do properly, then this kind of attack is mitigated and nothing can happen anymore. The second assumption would be that persistent XSS usually comes via post or via files. Someone uploads something, someone posts something, some HTML is hidden in there that is not good. And if we filter this properly, and if we tell the good HTML apart from the bad HTML, then we can fix this problem. It's not a problem anymore. And same with DOM XSS, the third assumption. It comes from DOM properties. We have some sources, could be the address bar, could be document cookie, or whatever the attacker can influence. And we have some sinks somewhere in the JavaScript business logic. So if we fix these things and make sure that the output is again properly encoded, then nothing can go wrong. And by following these 3 rules, these 3 assumptions, and handling uploads property, and maybe setting some security critical HTTP headers for our websites, we can more or less mitigate cross-site scripting attacks entirely. And we can see that the big applications like Yahoo Mail, like Google Mail, Hotmail, and other applications actually do so. So if they had an XSS, that would be catastrophic. Like, everybody could hijack your mail account or whatever, and we don't want that to happen. That telling apart thing for persistent XSS is pretty hard. So it's not easy to know HTML that well that you can predict which HTML is good and which is bad and which can potentially have negative effects for your users. So there's libraries to do so for you. Like, they're going to take that hard job away from you and going to do it on their own. And there's, for example, the OWASP anti-SAMI/XSS filter project, which is a good library. Like, it's sound and working well and hardcore tested. And it's just working well. It's, I think, written in Java. And there is the HTML purifier for the PHP people. And again, like a very good library, very well tested, often bypassed, but then fixed, and it's just working fine. Then there's Safe HTML from Microsoft, there's JSoup, which is shitty, don't use it. And there's many others out there, like KSAS and HTML Lot. Like, there's essentially tons of anti-XSS libraries that you can use. But they do a more or less good job, and they're being used in web mailers, in content management systems, for social networks and the profiles that users can enhance with HTML. They're being used in intranets and extranets, in the www, in messenger tools, and mail clients, mostly on the server. And they are more or less the major gateway between fancy user-generated rich text and a successful cross-site scripting attack. And like I said, these things work quite well, so they're well tested, and we can just safely assume that the most popular of them, aside from JSoup, have no bypasses anymore, and that even for a very, very advanced attacker, it's not possible anymore to just walk in and execute script on your websites. And if they wouldn't, shit would actually break, because if they wouldn't work anymore, then all of a sudden, most of the major websites out there would be vulnerable, and that wouldn't be good. But now the question is, what can we do to fool these tools? How can I, as an attacker, still go around these tools and make use of an interesting property inside the browser to bypass these tools and still attack your precious websites? And the question is, can we actually bypass every single of these libraries? Is that possible? Can we find a way that is so generalistic that we can bypass every single XSS filter? Maybe we can. So this lady has the perfect kitchen. And she has the perfect MacBook, and she has the perfect phone, and she's probably syncing something right now. And she's living in a very, very convenient place. Like, everything is optimized here. The kitchen is white, and she has a coffee, and that's even empty. And she feels very convenient, and that's good, because convenience is important, especially when you talk about security. So some decades ago, Microsoft added a very convenient DOM property that was non-standard. And it was available in Internet Explorer 4. And it allowed us to manipulate the document object model without really manipulating it, but have the browser do the dirty work. And this property is called innerHTML. Who knows innerHTML? That is some people. That is good. innerHTML, as we all know, gives us direct access to the element's HTML content, read and write. And when we modify something inside that element, the browser does the nasty stuff for us. So we don't have to do it black metal style. So this is like the true stuff over there. Like, it's using the DOM APIs. We go ahead and it's just like var my ID, span, document, create element, and so on. And just like, we use all this code to do a simple modification of a DOM element on our website. And who wants to do that? The easy way is below there. We just see, hey, we have a span, we grab it, and we just set that span's innerHTML, and done we are. We don't need that overhead. We don't need all that code. So it's significantly more simple and more convenient. There's pros and cons, of course. One of the pros is it's easy. It's damn fast, so it was tested, and if you have a look at the benchmarks, then you can see that innerHTML is meanwhile that well optimized that it's even faster than the classic DOM APIs in some browsers, not in all. It's now a standard, so the W3C picked it up and it's standardizing the whole thing, and it just works. It's just working perfectly fine. It was non-standard once, but the other browser vendors saw it and says like, hey, that's an awesome property, we're just gonna reverse engineer that thing and build it ourselves, and meanwhile it's a standard. It's even got a big brother, who's called outerHTML. I think I don't have to explain what this thing does. There's some cons. It's a bit bitchy with tables because tables are complex. Like, tables in HTML are a very, very complex beast, and you just don't want to deal with them, and innerHTML just usually doesn't work out. It's a bit slower in older browsers, but who uses older browsers anyway? You cannot really use it in the XML world because XML doesn't specify it, and XML is clean and strict and doesn't allow these kind of dirty things. And it's of course not as true as real DOM manipulation. But anyway, it's a good property. And I wanted to know how many people or how many websites are actually using this property. So back in the day when Google Code Search was still alive, rest in peace, and Google, please bring it back because it was awesome. I had a look with Google Code Search, crafted a small regular expression and said, hey Google, can you tell me how many libraries out there are using innerHTML? And Google said, yeah, about 184,000. That's a lot. And then GitHub got its code search feature, and I asked, hey GitHub, how many of your projects are using innerHTML or outerHTML? And GitHub said, about 1.2 million. So that is a lot. And I wanted to know about the Alexa top 10K, so I wrote a small tool that was crawling the websites of the Alexa top 10K and said like, hey tool, how many of these websites actually use innerHTML? And the tool said, well, 75% at least, just on the index page. So people use it, and that's good. Another field of tools or of libraries that make heavy use of innerHTML is, of course, rich text editors, because without this convenient property, it would be really hard to actually deal with that stuff. Like, if you would do all these transactions and all these transformations with content editable or with the true DOM API, you would just die, and we don't want that. So, in essence, rich text editors all use innerHTML, and even they are everywhere, like in CMS systems, web mailers, email clients, publishing tools, and so on. So, bottom line, this property is being used a lot. Now, the question is, what's the problem with all that? Is there a problem at all? Maybe there is. So we have to make another assumption, and we have to ask ourselves, so is there some kind of idempotency? So does it mean if I put a string in there and I set a string, or if I set the innerHTML of an element is the resulting HTML exactly equivalent to what I put in? And of course it's not. Like, it can't be. Because if I, for example, pour in broken HTML in string form, then the browser needs to deserialize it and make something out of it, create a valid DOM tree representation of it. And if the HTML is broken and the browser wants to attach it to the DOM, then he can't or she can't create a broken DOM tree, because then you would eventually invalidate the document or destroy the structure of the document, and we don't want that. That mustn't happen. So if, for example, there is like a div that is opening but not closing, or there's a bunch of only closing divs, and you attach them to innerHTML, you would break the document, and you don't want to do that. So browsers do have to change what's coming in, and they have to do this for performance reasons, for bad markup reasons, and to make sure that there is no illegal HTML inside the same DOM tree. And I wanted to know what the browser is actually doing, because I find this very interesting that I give something to the browser, and then the browser starts to think, says, I know it better, and I'm going to do something with that, and then I'm going to apply it to the DOM. So like, okay, what are you doing then, browser? Like, show me what you're doing. And I created a little test tool, and this test tool is notably simple, and it's public, you can use it. And it is available on html5sec.org/innerHTML, and it more or less consists of a text area, and a div, and another text area, and another div. Whatever I type into this text area, can everybody see this? Is this big enough? Otherwise I would zoom. Is it cool? A little bit? Alright. Better? No? Alright. So whatever I type into this text area, the value is being taken, the value is being mapped to the inner HTML of this div, and then again, I take the inner HTML that results from this div and map it to a different text area. So this way I can see what the browser does. And let's have a look at this example. Here I'm saying hello, and I'm saying it in a very bold manner. And this is IE8. Oh, I like IE. And IE8 is old. And IE8 doesn't know anything about HTML5 and will never do. So we can have a look at what's happening here. So we have my input here, and just so I can remove it and just like add these things. And I can, for example, say, whoops, goodbye. And we can see whatever I type here arrives here, and then the result from the actual inner HTML is being shown in the text area. We can see it's not identical. Here I'm using a lowercase b, and down here it's an uppercase b. So the browser does something, the browser changes something here. And of course, in HTML4, per specification, element names are supposed to be uppercase. So the browser says like, yeah, you're giving me lowercase tag names, but I know it better, it should be uppercase, so I'm gonna uppercase them for you. So alright, good, fine, do that. I can live with that. And now I'm going to be a bit more nasty, and I'm going to go ahead and say, for example, all right, let's be a sloppy guy, and let's just remove the closing B element. And the browser says, like, if there's no closing B element, then you could break things, so I'm just going to add it for you. And thank you, browser, that's nice. So, cool. And the same with, for example, if I nest stuff, or if I use, like, a closing element that is not supposed to be here, or there's no opening element. So if I put a closing div in here, then the browser says, like, that's the closing div. If I would apply that to the DOM, then shit would break. So I'm just gonna open it for you and then use the closing one and then close the B just in case. So, okay, cool browser. That's nice. And you can see things happen. Browsers do transform and sometimes even add a lot of markup or more markup than we originally used. And there's a funny effect, for example, with HTML comments. So everybody knows comments, right? HTML comments, they're super easy. Like, there's nothing to misunderstand, nothing ambiguous here with the comments. Let's have a look at comments. If we, for example, write a simple HTML comment, that would be one, right? And you can see it appears here and everything's fine. Our comment is here and our comment is there. So exactly the same thing. And if I, for example, add another minus, then we have 5 minuses. That's what we expect. But if I remove one of the dashes, then we can see here I have 3, but here I still have 4. So again, the browser does stuff, and the browser transforms and mutates stuff. And if I remove another one, then we still have 4. And if I remove another one, then we have 5. Now, what? And that even makes sense, because for the browser, this is a valid opening HTML comment, and this, consequently, is a valid closing comment. Yes, that is the case. So the browser says like, I see that there is a comment, so I'm just going to add these 2 dashes, and then we have a dash in the middle. This is the actual commented text, and then we have 2 more dashes that close the comment. So it makes sense that we have 5 of them and not 1. You can see we're going into a direction where it's getting weirder. Oopsie. There is similar effects that happen to C datas that you can add to your markup. And depending on what browser you're using, the behavior changes. So if you play the whole thing in Firefox, then it does something else than in Chrome and slightly different than in IE. And in IE, if you change the document mode to an older document mode, you can see that again there's changes. And we're slowly arriving in the country of unpredictability. Like you cannot predict anymore what's going to happen. But it's not that bad yet. And the question that might arise is now, what does this whole thing have to do with security again? And let's have a look at an old story from Japan. So back in 2006, a fellow desk worker working in Japan, working on HTML, noticed a very, very interesting effect. So this dude was creating a document, and he was mainly working with Internet Explorer, and he had like the perfect document with forms and stuff on there, and he typed stuff in there, and he was happy, like his job was done. And last part of his job was actually to send this thing to the printer. And he sent this HTML page from the browser to the printer, and he walked up to the printer and took the piece of paper, and he was like, what the fuck is that? Because he realized that it was not the same anymore. The contents of the form elements that he was creating in HTML were actually bleeding into the document. So the form elements on the printed page were empty, and their values were in the document, whereas on the HTML page, the form elements were actually filled with the values, and everything was sane and perfectly alright. And he was like, what is that? And he freaked out and was like, I don't know what to do here, because that was like really an esoteric problem. His HTML was perfectly fine, perfectly correct, but still the printer would do stuff with it. He filed a bug and was ignored, and nothing really happened. 1 year later, the fellow researcher Yosuke Ashigawa analyzed the problem and discovered a first pointer for mXSS. And now I think we can answer the question what mXSS actually means. It means mutation XSS, mutation-based cross-site scripting. We saw that the browser mutates things, and now we're going to go ahead and use this feature to create a cross-site scripting attack. Let's have a look. So the next demo I'm going to show here requires Internet Explorer 8. It does not work in a newer version anymore. So let's have a look at this tool again. And we type, for example, like yes, and then hello, and we close the whole thing, and we're nice, and everything's good. And now we remember that HTML not only has elements, but another very cool thing, and that's attributes. Everybody loves attributes. And we're just going to add an attribute. And we want to use something that is not so obtrusive, so we just give that fellow a class. So we say like class equals empty. So, hey dude, where's my class? There is no class, because IE says, empty class, doesn't do anything, just omit it, save money. So the class is not going to appear. And once we go ahead and say like, all right, but we want that class, and we want to put something in there, and we just like class equals foo, then we realize all of a sudden the class comes back, and here we have class foo. But what else do we notice here? Like what else is different here? Who sees that? There is no quotes, right? IE just says like, quotes, completely overrated. Let's just leave them away and save some money here. And you might ask yourself, all right, so I'm a nice developer and I quote my stuff and IE removes that quotes for me to save time and performance and thereby money. That's not good. Maybe we can make an injection out of that. What about if we just use a white space in here and try to break out of this constructor on there? The second we add a white space, the quotes come back. So someone was there before. And why not try, for example, like a single quote? The second we add a single quote, the quotes come back. And we cannot do anything bad here. So this is like, IE says like, hey, I know what you're doing here. I'm just going to add these quotes now. So just so you know. And we try to remember what kind of ways do we have to actually delimit attribute values. So we can have no quotes at all. We can have double quotes. We can have single quotes. But what else is there? Who knows it? Like the older people here in this room might still know this. I'm old. So we can use backticks. IE allows us to use backticks as attribute value delimiters. So let's try the backtick. And we can see the backtick doesn't cause the browser to add these quotes. So we have a problem now. Because here we have a perfectly valid class that is quoted. We don't break out. It's super harmless, benign markup. But down here, we don't have any quotes. So now we have an empty class. So that means that if we write something afterwards, then we have the new attribute. So let's try this out. Click equals alert. So we click this fella, and there's nerd. And that's bad. That is really, really bad. Why is this bad? It's bad because we have perfectly sane markup here that every cross-site scripting filter would say, like, that's cool, I don't see any violations here. But once the browser touches it and reads out the innerHTML and writes it back to the document, the quotes disappear and we have an injection. So this is like a universal bypass. This is really, really, really bad. A big web mailer that is out there that starts with Y and just funded a lot of things, was affected by this for ages, and they didn't even know how to fix this. And it is a hard question, like, how are you going to fix this? Because the browser does something that the application can't really predict. Anyway, this is bad, but it's not too bad, and it's also not new. Also, it's not that bad anymore, because there's a patch. So last patch Tuesday was actually covering this issue, so this bug is fixed even in IE8. So it's neither new, and it's not so bad. It's just interesting and shows what we're talking about here. But if you like this, we can continue, because we do have new, and we do have really bad. So, this is one of the demos where people usually leave the room, or call their emergency contact. So, as I mentioned earlier, IE8 naturally doesn't know HTML5. Like, how could it? How could this poor thing know HTML5? And that means that HTML5 elements are unknown elements for IE. So if you go ahead and, for example, say like, hey, we have like this awesome article element, or let's just use the aside element or whatever. So like aside 1, 2, 3, and then we close the thing because we're nice. Then we realize something strange, and that is that the opening aside is not here, whereas the closing one is. And that is the behavior for unknown elements. And you might ask yourself, why is that happening? So, all right, okay. Interesting. So I didn't see that coming. So you add some content in front of it, and all of a sudden it reappears. So no content, opening tag disappears. You have some content, and there it is again. So all right, that's weird. But if you have an unknown element, and if you know that the browser is treating this thing as an unknown element, you can ask yourself, so how can we teach the browser to learn about this element, to teach the browser on what to do with this thing? And one of these ways is to use the XML namespace attribute. So we can go ahead and, for example, say like XML LNS equals something. And then you see, contrary to the empty class, which was just swallowed and didn't appear, the XMLNS does appear. So we are in a different code branch here. Like the browser is in a very, very different place executing these things, because there we have the empty element, the empty attribute, and formerly we hadn't. So now the question is, what is going to happen if I add like an arbitrary character as the content for the XML namespace attribute? Like who's going to be able to predict what's going to happen? Who knows it already? So let me just add the character A. And now watch closely what's going to happen here, what the browser is going to do internally. Whew. Hello. Who are you? Is that Cthulhu? That is Cthulhu. IE decides to append like a kind of pseudo processing instruction that is not really a processing instruction. It's just like, what in fuck's name is that? What in fuck's name, namespace, prefix, what is that kind of delimiter? Oh my god, and what is that? And then we have the actual element in its actual representation without any modifications. And again, we can see something interesting here, because one of the parts that we provided inside the attribute is unquoted. So we have an unquoted A here. So if, for example, use the foo, you can again see unquoted foo, and that is bad. So we can maybe just do this. And then we can maybe just do this. And that's that. So we broke out the element, and we have a new element, and we can just go ahead. For example, img_src equals x on error equals alert 1, and there we go. Yes. There we go. So again, we have a perfectly valid attribute value that is not breaking anything, that is not looking suspicious, aside for some quirky characters in there, but it's fully sane, so no one broke it. And again, the XSS filter would say, that's cool, like I don't see any bad in here. But the browser says like, oh, I see a lot of things in here, and I'm just going to be busy and do stuff with it, and then that happens. So that's pretty bad. But this is not mine, so I didn't find it. Someone else found it, a guy from Russia called Lever1. And I played with it, and I found another one that's even worse. Let's have a look. So, yes, I gotta get away from this thing. So, here we've been nice, and we've been closing our element. And now let's not be nice, let's not close it, let's remove this thing, let's remove the politeness. And we can see that once we remove the closing element, then this weird markup explosion, this huge processing instruction disappears. So apparently it only works when the element is closed. So again, we're in a different execution branch, like we're somewhere completely different in the browser code. Like, I don't know where, but somewhere else. And now we ask ourselves, like, what other ways do we have to specify a namespace? So we have like the classic URL notation that's just like, hey, look, there is like something that is namespacey, look it up. Or we can use the URN notation that is using colon as a separator, like this kind of package-like syntax. So we can, for example, go ahead and say like, hey, my core package is like X, and then we have like colon, and then we have Y. And something else happens. So all of a sudden we have a Y namespace and a colon and a site, and then XML and S, X, colon, Y. Well, that's new. And, can we do interesting stuff with that? We can maybe go ahead and say like IMG. But, yeah, nothing happens. I mean, it's an actual namespace. And the browser behavior does make sense in a way, because it takes like the second part of the namespace and maps it in front of the element, and then like, sure, could work in theory. But, oh no, we don't want that to happen. Just 1 second. I better postpone this for a long time. Thank you. What is one of the characters that you must never use in a namespace? Like, what is like poison for a namespace? The white space, of course. You must never use white space in a namespace. I think it's even forbidden by the specs. So once you go ahead and add a white space to a namespace, then the browser should say like, stop, don't do this. This is forbidden. Let's use some white space. Whoops, we have an image element. Wait a second, no, really? Yes, we have an image element. So once we add like an illegal character to the namespace, we create an image element, because now we don't have a namespace that is called image whitespace, and the browser takes that as an image element naturally. So there's like a complete confusion here on what is to be done and what is right. So we again go ahead and select source equals X. You know it already what's going to happen. So, and there we go. And yet another way where we can use completely harmless markup that doesn't contain any script elements or any obvious attack, and force the browser to make it into attack by just having a look at the innerHTML and writing it back. So that is bad, and that's how I reacted. That is pretty bad, but it's not super bad. Like, there's worse. For example, a few websites actually allow users to submit XML and S, like, and why would they? Everybody allows article and aside and these things though, but still, like, no XSS filter actually accepts XML and S. So we don't have a huge attack surface here. Also, it's not working in the standards mode of IE, it's only working in the older modes, in the older document modes. Everybody knows probably that we can force IE into rendering a page in a different document mode by using either a header or a meta element. So if we put this meta element on our site, then the site will be rendered in IE5 mode. Or if we change it to IE7, then it will be rendered in IE7 mode, and so on. So we can force the browser to not render the page in standards mode, but in older modes, and then we can kind of reactivate the attack. We can also use iframes to force the browser into doing these things. I will be going to learn about this later, and it's really nasty. Anyway, it's not entirely bad, and there's worse. So, and we want to see worse, right? Like, we want to see really bad. I got bad. Everybody loves style attributes. Style attributes are such a great idea, just smooshing two languages together that are completely unrelated and just putting them in an attribute, like that was a great idea. Oh my god. So, like, this is the biggest challenge for every parser to, hey, HTML, oops, there's something else. Oh, no, it's CSS. Oh, back to HTML, it's horror. So, style attributes, we have them, and it's just CSS, right? I mean, we can do nasty stuff with CSS. We can, for example, use CSS expressions in Internet Explorer to execute JavaScript. We can use some quirky stuff in Opera, rest in peace, Presto, I miss you, to do crazy stuff and to execute JavaScript. We could do crazy stuff in Firefox with -mods, -binding, and there's a lot of attacks you can carry out by just using CSS, but in its core, it's just a layouting thing, and it's quite harmless. So, whenever we have style attributes, they're usually being accepted by an XSS filter, so it's just like color red. Color red is cool, just make something red. Now let's have a look at something that is very interesting with style attributes. And we can even use a newer version. New. So, you create an element with like p style equals something. I'm just like color red and red. And we can see it's red. That's what we want. I'll make it a bit bigger. There's differences again, so the browser goes ahead and says like, lowercase style attribute property names. I better put them uppercase, all in capitals. And I better put a space in here because I want that space and my layout engine likes this, so I'm just going to do this for you. But otherwise it's cool. There's no problem here. So we have just a red thing. And we can also, for example, go ahead and say like font family and say like, hey, I want you to be monospace. So it's monospace. That's cool. Doesn't hurt anyone. And now we have like this typography dude in our company, and he created like an awesome font and wants us to deploy this on the website. So we have to give it like a string and say like awesome font. My writing skills are not the best today. So now the typography dude decides like, yeah, I have like Scottish origin and I want to call my font O'Malley's Bar. So he has a single quote in there. And we're like, okay, then call your font O'Malley's Bar. Fair enough. But if we add a single quote here, then of course we break the integrity of this string. And this doesn't work anymore. So we have something that is completely broken here. We can't do this. But luckily, CSS gives us something that is called CSS escapes. And these are these little fellas that use the backslash and then the hexadecimal ASCII table index of the character that we want to use. So if you, for example, want to express the A, we go backslash 41. And then we have uppercase A, as you can see here. And if you want to express the B, then we go 42 and so on, but you know it. But the interesting thing that we see here, and maybe you noticed it already, is that up here we're using the escape, and we're using it for safety reasons. And down here, the browser decodes the escape into the canonical representation of the character. And that leads us to thinking, is that for all characters? Is that, for example, also for the single quote? And we try it out. We see, oops, that's also for the single quote. So we can inject CSS by only using escapes, like the very security feature of it, like the recommended way of doing things safely. We can abuse that and just execute CSS code with that. Let's have a look. So 3B, and then we go X, and then we go 3D. And you might ask yourselves, like, why 3D? In Internet Explorer, the colon and the equals is identical, so you can use both in CSS. Pro tip. And then we go expression. And then we go 3B again. And I'm not going to do the alert right now because it's going to cause a loop. So I'm going to inject some JavaScript that is going to modify location hash. So once you see something happening here, you know that the JavaScript executes. So we just go and say like location.hash equals 1. And whoops, it changes. So we execute JavaScript. That is not so good. And we have, again, nothing bad in here. We're not breaking out. We don't have anything that is being detected by the XSS filter. And in fact, this kind of attack bypassed every single filter out there because they say, like, yeah, he's using escapes. Like, that's fine. I can live with that. No, we can't. And there's an interesting trick. So let me change this fella. It can take some time. I hope it doesn't. Oh, it doesn't crash. Good. Let me change this fella to the 22, which is the representation for the double quote. Again, it will become a single quote. Because IE thinks, hey, I want to deserialize this, but if I deserialize this to a double quote, then I would eventually destroy the document structure because there is double quotes already, but they're quoting the style attributes content. So let's better not do this, and let's better fall back to the single quote and use that. So that's an even less obvious attack that we can use here. And that's pretty bad. And again, a lot of tools out there were affected by that. A lot of webmailers were affected by that. And almost literally all XSS filters were affected by that. So this worked in Firefox, not with CSS expressions, but with other things. They fixed it, and this worked in IE, the older document modes, and there's still like work going on to fix this. And that's a very bad thing, because this is like the first time that we actually have something completely sane that is completely accepted by any HTML parser, by any XSS filter, and completely left through. And what's even worse, that there is tons of variations. So there is just like so many ways. I was playing with this thing for 2.5 years, and it took me like 2.5 years to get permission to talk about this. And in these 2.5 years, we found tons of stuff. And I can't show you all of these due to timing constraints. But I want to show you two. So if you, for example, go back and hopefully not crash this thing. I think it's already too late. It's just getting slow. Just 1 second. At some point, it should come back. Oh, I can maybe just use this. Right, it's always good. So if you go ahead and, for example, and say p_style equals something, and then we have a string, and then we say foobar, then we just put it into a proper document mode, and then see what we're doing here. Then you can see we have the quotes here, we have the quotes there, and everything's fine. There's a little bit of switcheroo going on here, but so far okay. And if we go ahead and, for example, say font, family, and we do something like this, then it's exactly what we expect. So we see this, and we see that, and that works. Everything's perfectly quoted. And I wanted to find out if there's like maybe some crazy properties, and some crazy properties doing stuff that I don't expect. And I wrote a small fuzzer and had a look at that. And I discovered that there's one property that is surprisingly evil, and you wouldn't guess if you see the property because it really looks harmless. Just give me some time to reload the page. Oh, please come back. Oh, maybe this one works. No, I have to readjust the browser. Just 1 second. And here we go again. So, if we have something like this, like you could see before, everything perfectly quoted, we get what we expect, like double quotes, colon, single quotes, everything's fine. And I wanted to find out if there's nasty properties that do other stuff, and that don't force us to, for example, use escapes in here and potentially bypass filters that listen for the backslash and stuff like that. So I was fuzzing a little bit, and I was discovering something quite interesting, and that is that there's a property that is very, very tiny, and no one knows it anymore, and no one uses it, but it's harmless or considered harmless, but in reality it's a beast, and it's like really nasty. And this property is called border spacing. So what will happen if I use border spacing instead of font family? That's right, and have a look. Who can see the difference? Border spacing is just removing the quotes. It's just like, hey, there's quotes, but I don't like them. Bye-bye. So here we have quotes, but here they're disappeared. So we don't have to escape anything. We don't have to inject anything. It's doing it for us. Like, what in God's name is that? And it's getting even better. It's getting even better. So, for example, we can go ahead and select font family foo. So you can specify more than one font family. And if you want to specify more than one font family, and then use the comma as a separator. And once the comma as a separator is there, it will like use the other consequent fonts as a fallback. So if the first font is not there, it will check for the second font. If the second font is not there, it will check for the third font, and so on. But this should, of course, not happen once we're inside a string. But if we add a comma now, then again, the quotes disappear. So we again kind of weaponize the whole thing by just adding one harmless character, and you see, no quotes anymore. So we can break out, we can create the CSS expression, and have another XSS. And in my most feverish dreams, I wanted to find out if there is a way to exploit like this weird \22 issue. Like, I wanted to destroy the markup structure. I wanted to destroy the document structure and find a way to use CSS escapes to actually attack the whole document, not only the CSS inside the attribute. So I wanted to really break out and using escapes. And I was like, can that be possible? And it's not possible here because, as you can see, once we use the 22, it turns into the single quote, and we cannot break out the attribute. But I was always playing with the property value, and I didn't bother playing with the property name. So once we go ahead and add a backslash and the 22 here, then all of a sudden we do break out. So we have a double quote here, and now we ended the style attribute with the CSS escape. And that's not good. So we can go ahead and, for example, on click, and then we use the equals again, and then we have a space, and then we say alert, and then we have parentheses, and then we have a 1, and then we have the closing parentheses, of course, and then we have the 2f and the 2f for adding a comment making it valid. And this is a bit weird here, and there we go. And we can maybe just quote it a little bit to make it sane. So now we have a P with a garbage style attribute, and then afterwards we have an on-click, which says alert 1, and then we have some garbage afterwards, and if we click it, then we of course get the alert. So we can use CSS escapes to destroy the document structure. Like, that is not what CSS escapes were designed for, but it still works. You can see it's bad, and we can do nasty stuff with it, and we can force the browser or trick the browser into showing completely unpredictable behavior. Like, we cannot know these bugs unless we found them. Like, we cannot create a rule or a formula that helps us to find out what's going on there. We can basically only use these bugs to kind of reverse engineer what the developer back then was thinking in implementing this kind of code. There is more applications for this kind of mutations. Chrome, for example, badly messed up with text area. So everything that was inside the text area, even if converted to HTML entities, was being deserialized and then causing an XSS, found by Eduardo from Mexico and no Google. And Firefox badly screwed up with SVG, with scalable vector graphics. So we had like an SVG element that contained a style element and then contained an entity that is even broken for the lesser than, and then was followed by the classic image element that's giving us the alert 1, all in entities, and would still execute just right away because inside XML, entities are being deserialized if not inlined into a comment or a CData section, and that causes an XSS. And similar happens with the listing element in IE. We have like the pre element for pre-formatted text. We have the code element for code, but in IE we also have the listing element for listings. And this is one of the elements that completely deserializes everything. And even if we use entities, if they're inside a listing element, we're going to have an XSS. And if you wander off from text/HTML to the fascinating world of text-HTML, please don't, because it's bad. Then we have even more mutation behaviors and even more quirky things that are gonna have surprising effects. Everything that is inside C data will be decoded as well, so everything will be shown in the canonical representation and dissolve the decoding, the encoding, and do stuff. There is worse things happening inside inline SVG, so whenever you have the chance to avoid inline SVG in your websites, do it. Don't work with inline SVG. It's so broken, it's so immature. That was a bad decision to smush these two things together, HTML and SVG. MathML, same thing, not mature yet. Now the question is, who is actually affected by these issues? And we're slowly coming to the end of this presentation. Most existing HTML filters and sanitizers are affected. So we contacted some of them, not all of them, because at some point the fingers started to hurt. But those we contacted actually fixed the bugs, most of them. HTML Purifier itself, like one of the best filtering tools out there, was affected, and there's still some small bugs in there that we can use to play around and get something in. JSoup is broken, anti-semi is broken, HTML Lot completely, entirely broken, doesn't protect against these kinds of attacks at all. And even Google Kaha, which is considered to be like one of the academia level, super top-notch filter projects by Jasvier Nagra and Mike Samuel, was also broken. Meanwhile, it's fixed, but at the time of writing was broken too, and I said like, hey, Jasvier, please fix it, and then he fixed it. All tested rich text editors were entirely broken, and we could use attacks inside their content, because these mutations also happen if you use content editable, and if you edit around in it. If you use undo or redo, then all these mutations are going to happen as well. Most existing webmailers were affected. We contacted some of them and they fixed their stuff, and then things are good again. And the crazy thing here is that basically anything that obeys to the standards is affected, because the standards say do it like this, but the browsers do it like that. And this kind of mismatch between the recommendation and the actual implementation causes a security bug, and this is not a rare pattern. Like this kind of pattern you see all the time. This is the affected page of HTML Purifier. You can see the backtick trick is working. Here is the affected page of Google Kaha. You can see the backtick trick is working and the expressions are coming through. And here is HTML Lot, the smoke test, and you can see it's affected as well. Maybe you can't see because the font is shitty small, but we can see that the kind of entities are here. And what we can also see is that one might think initially that HTML Lot is not affected because they double encode the entities. But the good thing is, or actually the bad thing, the mutations, the deserialization of the entities works recursively. So if we access innerHTML once, we have one decoding step. If we access it twice, we have the second decoding step, and so on. So even if you use like quadruple encoding for whatever reason, we just have to access innerHTML 4 times, and then we have it completely decoded again. So that's not so nice. That was basically the outcome of showing this behavior to actual website owners and saying like, all right, so that's your website and you have a ton of bugs and there is no really good silver bullet to fix these bugs. So we're not really sure what to recommend here. But there is recommendations. If you have a fancy website that is really just, you have a lot of way to customize that and to tweak it, then you can do interesting things to completely mitigate these kinds of attacks on all browsers. First of all, make sure that your website is only running in standards mode. Don't use IE7 mode, don't use IE5 mode, Quirks mode, or CV mode. Just make sure it's running in standards mode. Avoid getting framed, use cross-frame options. Make sure that you always use the naked doc type. This little thing is important. If you use an HTML4 doc type, don't do it, because then your site can be patched down into another document mode again from external iframing, and that is bad for you. So make sure that you use this and no other doc type. Use CSP if it's available. Motivate users to upgrade browsers. Avoid SVG and MathML. Actual websites with a lot of maintenance, patch your filters. Make sure that certain characters cannot be inside style elements or style attributes. Employ strict whitelists. Make sure that backticks can't come through. Make sure that backslashes, CSS escapes, and weird invalid CSS doesn't go through, and so on. Be extremely paranoid about your CSS. Don't obey to the standards. Obey to what is making your site secure or not. And for pen testers, you have like the universal joker. Like for me, that was a nice behavior of a process. We have written a small library that you can ping me for later on offline that is working completely in JavaScript and that is intercepting innerHTML access and doing the sanitizations for you before the mutation actually happens. That works too. We tested it with a lot of HTML and it works quite nicely. So if you want to play with that, it's basically available under the whatever you want to do with it license. You can make sure that your website is, for example, not using any CData sections, or that injections of these kinds are not possible. And again, avoid SVG whenever possible. Don't use inline SVG because it's too broken, like it's not usable, it's not ready yet. So we're coming to the end of this talk. The takeaway. What was in for you? For a pen tester, there was like a wildcard bug pattern, like something really new that the pen tester can use in almost every assignment. And you will always find bugs of that manner. So whenever user input hits innerHTML, you will have a bug. For developers, you have new infos to project your app. For browser vendors, you have a new pointer to a problem zone to watch. And for specifiers, there's maybe some hints for upcoming specs. And indeed, there is an upcoming spec. So here is the innerHTML spec, and people are working on it, and people are seeing these bugs and are aware of these bugs, and create specifications that push browser vendors into the right direction in treating these kind of things properly. And that's a good thing. So wrap up. We saw some ancient HTML DOM in browser history, like a story from 2006. We have seen some old but yet unknown attacks being revised, and we saw some very fresh attacks, Pentest Joker, and we most importantly saw guidelines on how to defend your website against these kind of things. And we also saw the W3C silver bullet that hopefully can be used or trusted in 2015 or maybe later, when hopefully there's not too many legacy browsers around anymore. And that's that. So if you have any questions or comments, let me know. And one last thing I want to say, this is not solely my research, mostly but not solely. So there is Gareth Hayes from UK who contributed, Yoshiki Atagawa, Leverban from Russia, Eduardo Vela of Google, Dave Ross from Microsoft, and ultimately Stefano Di Paola who helped. And with all these guys, without all these guys, that wouldn't have been possible. So that's that. Thank you very much.
We're a little bit low on time, so I think we just take one question. So if you pick one, that's...
So whoever has a question gets the phone. That's like very, very attractive, I reckon. Any questions?
Just pick one. Pick one to ask the question.
Yep.
Thanks for an interesting talk. I think the problem with security, at least for me, I feel, is that there are so many vulnerabilities, and the only time that I really care about it is when I go and see a talk from a guy like you who really knows all these particular vulnerabilities. So I'm thinking, is there some project to like parse a complete web page to take like the generated DOM tree and match it against like a database of known exploits?
Yeah, that exists.
All right.
I wouldn't say that's the best way to do things, but these kind of projects exist.
What is the
There's
best
even
way?
like reverse proxies that like pre-parse the HTML on the server and then compare it to well-known things or bad things. But if you would work with known exploits, you can protect against the known exploits, but you cannot protect against the unknown exploits, like the stuff that we research. So I don't believe in blacklists, and that would be a blacklist. I rather believe in whitelists, so you match and make sure that only the things that you allow are in there, and then you're better off. Not against these kinds of attacks, but you're still better off. Did this answer the question, Brian? Yeah. All right, cool, thanks.
Thanks.
All right, thank you.